Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 1.2.4, which is Describing a Graph. The basic premise of this chapter is so that when we look at a graph, we know how to just describe it, not just in terms of its shape, but just things in more detail. Getting you to, when you look at a graph, what can you determine about not only its shape, its size, but what can we determine about its behavior? So today's lesson is largely a lesson in reading. So I'm going to paste a bunch of graphs on here, and then we will see how these are read. But primarily, before I do that, what you want to look for is, I'll even write these things out so that way we have an idea of what we're looking for. Describing the shape. We will learn how to describe the shape of the graph. One thing you should probably start looking for, especially as you hit Integrated 3 next semester or next year, is what is the behavior of the graph? These are some questions you probably want to start asking yourself. Is the graph increasing, decreasing, both at times? And we will see an example of when that happens. It wouldn't be doing it simultaneously, but it could be doing both within its own behavior. We definitely want to start looking at the types of intercepts that it has. So types of intercepts. So x-intercepts and y-intercepts. So these are the kinds of things we probably want to look at. And then of course I forgot, is the graph continuous or discrete? And we will talk about what that means in just a second. Let me go ahead and just pause it real quick. I will paste a few graphs on here, and then we will have that discussion. And we are back with our 4 samples right here. So what you want to describe is the shape, the behavior, intercepts, and what type of graph you're looking at. In this case, the shape of graph A would be definitely linear. Because it just grows in a line. And so I don't really see any other way you could describe this thing, but you could say linear with a y-intercept of 1, but we'll get there when we talk about y-intercepts. You could say the behavior of the graph, is it increasing, decreasing, or both? When you read a graph's behavior, and this is going to pay a lot more in Integrated 3, when you read a graph's behavior, we read from left to right. So what's happening if you were to start from the left and go to the right? Sometimes people will like to draw like a little stick figure right here. What happens to him? He's going to be skateboarding upwards on this line right here, which means if he's moving upwards, this thing has to be increasing. It's got to be increasing. Now, that's going to be true for graph B as well, but we will talk about that later. Types of intercepts. I believe it has both. It has both x and y intercepts on it. If you wanted to, you could, and these ones are scaled appropriately, you could say the x-intercept. Now, let's bear in mind here, the x-intercept, and let me type this out for you guys. The x-intercept is where the graph crosses the x-axis. Okay, so it has to be touching the x-axis, which is the horizontal axis. So where does this thing touch the horizontal axis? It definitely touches it, looks like at -2. I believe this thing is scaled appropriately. So we could say -2, 0. Right? Remember that from Integrated 1, the x-intercept always has a y-coordinate of 0. Likewise, the y-intercept would be 0, 1. And again, if I wanted to make a definition for that, I would say the y-intercept is where the graph crosses the y-axis. And of course, it does it right there at 0, 1. I'll even put those dots. I'll even put those dots in there for you. That way you guys can see them. So this is 0, 1 right here. That's our y-intercept. This is -2, 0 for our x-intercept. And again, I labeled those down there. Is the graph continuous or discrete? Right now, the only types of graphs that you might be aware of are continuous. And it's continuous because the line is connected all the way through. Now, if you look at the selection of graphs we have on here, there is one discrete graph, and it's pretty obvious which one it is. and then when we get there, I will describe why it is discrete. But there you go. There is a description of the first graph, and I will go ahead and move on to part B. So part B here, graph B, what type of graph is this? Now when you hit integrated 3, they will probably ask you to describe what it's called. But for now, I think it's okay enough to just say this thing is curved. It's a curved graph. And this is where the behavior is going to get a little bit more tricky. Because what you want to look at is, again, if you put yourself on a skateboard and you start riding this wave, if you look at it, it's moving upward, which means this purple figure, by the time you're way down over here, it's going to be way up. And again, I'm trying to have you guys use your imagination to see that arrow moves on forever. And because it moves way up for the rest of its life, we can say that this graph is definitely increasing again. So again, we're just describing its behavior. Does this graph have an x and a y intercept? It actually does have both, believe it or not. And the reason why is because this graph makes contact with both axes at the origin. So in this case, the x and y intercept, because it touches the origin, will both be 0, 0. So when that happens, you can kind of shortcut that and say that you have x and y intercepts at the same spot. And then is the graph continuous or discrete? It's definitely continuous. There's no gaps on this graph here, and they're not made up a bunch of solitary points. So graph E, what type of graph is this? And I will go ahead and give you the name of this graph, because eventually in this class you'll have to know what this is called. But you can call it curved if you wanted to, but really the name of this is quadratic. And you guys will learn what type of graph a quadratic is later on in the class, but it's good to start getting comfortable with those words early on. Now, here is the kicker. This graph is unique among the other ones because this is that situation where it's actually doing both increasing and decreasing depending on where you are looking at the graph. Of course, it can't be increasing and decreasing at the same time, but depending on where you are in the graph, you could either be increasing or decreasing. So from here, I'm going to put my skateboarder here, and he's going to cycle up the graph. So clearly we are increasing, all the way until right here where I drew that purple X, and this is where he's going to be flat. He's not doing either. So we can say that he's increasing for, and whenever you write an interval of increasing, you always want to do it in with the perspective of X in mind. So notice how we're always increasing when we're to the left, of the origin. In other words, for when X is less than 0. Alright, so he's increasing for when X is less than 0. So for any number less than 0, this skateboarder will be moving up the graph. And then, when X suddenly becomes greater than 0, now that skateboarder is heading down this graph, which means he's got to be decreasing for X being greater than 0. So this is that both situation where depending on where you are on the graph, you will be increasing or decreasing. So maybe this might be misleading where you might think it might be both at the same time. Again, I got to reemphasize that will not happen. It's not going to be both at the same time. This graph is definitely continuous. Again, it's not like it's made of a bunch of points. So it's definitely continuous. And I don't know why everything turned purple, but I'll switch back to white. Okay, and then the last graph here. Oops, and I totally forgot about the the X and Y intercepts. So does it have X and Y intercepts? It does. In fact, it has two X intercepts. I believe I'm looking at -5, 0 and 4, 0. So -5, 0 and 4, 0. And a Y intercept of looks like 0, it looks like 8. 0, 8. I kind of marked it up there. So 5, 6, 7, 8. I believe I'm correct. Yeah, so we marked up the X and Y intercepts. We talked about the continuity of it, decreasing, increasing behavior, and the general shape. Again, this lesson is all about your ability to read a graph and interpret what is going on. The shape of this, if I was to connect them, and I will temporarily, but we will ignore this blue line, this blue connection piece here, it's definitely curved. It's definitely curved. It almost looks like it's half of a quadratic, right? It almost looks like it's half of a quadratic. And if you wanted to call it half of a quadratic, I don't think I'd have a problem with that. This thing is definitely just increasing. Just increasing, because there's no point of decrease. It's not like there's another side here where you're decreasing. So you could just call it increasing. This thing, where it stands apart from the other, graph D, where it stands apart is this is a discrete graph, because it's made of a bunch of individual points. Remember, that blue line does not, that blue connection does not exist between the points. In fact, I believe I can paste. Yep, I believe I have another copy of it. Boom. And so it's definitely discrete, but it still does have an x-intercept and a y-intercept. And similar to graph B, because the graph touched the origin, it would be 0, 0. So here we are. This is where we're at with describing a graph, and hopefully you can carry on with the next examples. That's all I've got, so I will see you guys in the next episode, and please feel free to leave any questions in the comments area so we can talk about them in class. See ya.